सो बच्चों, हम लोगों ने क्लास 11th का फर्स्ट चैप्टर पूरा कर लिया, दैट इज अबाउट सेट्स. सेट्स में हम लोगों ने देखा था कि व्हाट आर सेट्स. तो सपोज यू हैव सेट ए like this, A1, A2, and set B, B1, B2, B3. These are two sets. सेट क्या होते हैं क्या नहीं होते हैं ये हम लोग पिछली बार देख चुके हैं. नाउ लेट अस लर्न अबाउट व्हाट इज कार्टेशियन प्रोडक्ट ऑफ सेट्स. कार्टेशियन products of now as the name suggest ये प्रोडक्ट है. तो अगर हमें इसका प्रोडक्ट इन दोनों सेट्स का प्रोडक्ट बनाना है, प्रोडक्ट इन द सेंस A into B, this is Cartesian product. Then we have to make the ordered pairs of set of the elements of set A and set B like this. First of all, let us take A1. A1, B1, A2, B2. Sorry, let us keep first for A1 and then A1, B3. So with this first element of A, that is A1, these ordered pairs with the elements of B is complete. Correct? Then we have to write the second element is there in the this thing. So A2, B1, then A2, B2, then A2, B3. Correct? So these are complete pairs, you can say ordered pairs of this Cartesian product A into B. Correct? If you see, let us see, suppose you have suppose your columns are A1, A2 and rows are B1, B2, B3. Then what are these ordered pairs? Just see. What is this? This is A1, B1. What is this? This is A2, B1. Like that, all these points are there and basically they are the distinct points. Correct? Position of these ordered pairs will be on this map. It will have the distinct position. Correct? A1, B1 has got a distinct position and A2, B1 has got a distinct position. Correct? So this is the meaning of basically Cartesian product. Now, what are these? These are ordered pairs. Now, if two ordered pairs are equal, then it is possible if and only if the corresponding first element and first elements are equal and second elements are also equal. Means suppose A1, B1, if they are equal to A2, B2, this means that A1 must be equal to A2 and B1 must be equal to B2. Then only these ordered pairs will be equal. Correct? Here, if you see, suppose you have number of elements in set A. Here, basically, it is number of elements in set A is 2 and number of elements in set B is basically 3. Then number of elements in your Cartesian product must be equal to 2 into 3 means 6. So here you see there are 6 elements. Generally you can write it as if NA equal to P, NB equal to Q, then NA into B will be P into Q. Correct? If there are two sets, one set A and set B, here we are saying finite numbers. Suppose set B is having infinite numbers or number of elements. Then your A cross B will also be infinite. Correct? Now, suppose you can have set A is there, set A cross, set A cross, set A. And A is having these elements. Then we can write it as, and all this A, B, C, basically they belong to A. Here A, B, C, it is called ordered triplet. Now, to understand this further, suppose you have ordered pair. You have ordered pair like x plus 1, y minus 2 equal to 3. Then if you are asked what is the value of x and y, so as I told you, if the ordered pairs are equal, then their elements are also equal. like x plus 1 must be equal to 3 and y minus 2 must be equal to 1. This will give you x as 2 and this will give you x as, sorry, y as 3. Correct? Now, let us see whether this Cartesian product, suppose you have P is, set P is basically A, B, C and Q, set Q is your R. Now what is P into Q? It is nothing but A, R, B, R, C, R. Correct? Now we see Q cross P. Then we can write it as R, then R, B, then R, C. With this, it is quite obvious that it is not necessary that P cross Q these two, P cross Q is not equal to Q cross P. However, number of elements will be same. Here, three numbers are there, our number of elements will be same. Then let us take, suppose you have set A 1, 2, 3 and set B is 3, 4 and let us take 4, 5, 6. Now if you want to find out A cross B intersection C. For this, first of all, let us find out B intersection C. B intersection C, what is the common element between them? It is only 4. Correct? And now we can find out A cross B intersection C. And what is this? This will be basically A is given, B is this thing. Now you have to cross product, Cartesian product. That will be basically 1, 4, 2, 4, then 3. So I think there is no doubt in that. This is how, if there are such type of questions you can solve. Correct? Then another thing is what is to be learned. Suppose your P is 1 and 2. Then what about P cross P cross P? If we write this, then it will be like this. We have to take first element of P, then again P is there, first element, then again P is there. This is your like this. So here, just see, these are all the ordered pairs of P cross. Correct. Now, suppose if you have R, it is set of all real numbers. We know that R is denoted by set of all. Hmm? Then what will be this R cross R? R cross R, basically we can write it as this thing. It is the ordered pairs of X and Y, and X and Y both belong to R. Means what is this? Basically this is coordinate of all the points in two-dimensional space. Correct? But this is your real number axis. This is also your real number. Then this R and R, this thing will be the coordinates of all the points existing in the plane. Likewise, R cross, this will depend coordinates of in space in three dimension. In three dimension, coordinates. Correct. Now, so if you are given A cross B, you are given A cross B as P Q P R M Q and M R. Then what is set A? Set A you can always find out. That is, set A is nothing but P and M, and set B is nothing but Q and R. This is the back method. Correct. So now let us go further. Next topic is basically relation. You can say relation. To understand relation, let us see. Your P is A, B, C. Sorry, you have to put the correct bracket. And suppose here it is Q is nothing. This is Ali, Bhanu, Binoy, Chandra, of the pair. These are the name of the person's name. Naturally, if we write Cartesian product, this will be or A Ali, then A Bhanu, and like that. There will be how many elements? There three is there. Here basically five is there. It means here you have 15 ordered pairs. Correct. Now let us find out. Suppose if we write a relation between these two, between these ordered pairs, we define a relation. Like we define a relation R equal to, there is a relationship between X is the first element and Y is the second element of the ordered pair, such that X is the first letter of the name Y. X is the first letter of the name Y. Y means, Y is basically denoted by this Ali, Bhanu, Binoy, Chandra, Divya, and X is basically A, B, C. So if we, and of course, X and Y, they belong to, X belongs to P and Y belongs to Q. So this is the relationship we have defined here. Then what will be the, what will be this? This will be basically, you can have the ordered pairs like this. A, Ali starts with A, then B, Bhanu, B starts with B, Bhanu starts with B. Then we can write it as B, Binoy, Binoy is there. And C, Chandra is. So these are the only ordered pairs which satisfy your relationship which we have defined here. Correct. If you see, R is what? R is the, R is nothing but it is the subset of A cross B. It will always be. If you define a relation, then you have to take out those ordered pairs which satisfy your relation, condition of the relationship. Correct. So this is basically the, now pictorially, if we can see, let us see, let us take this and another one is here. What are the elements? A, B, C. Here, what are the elements? Ali, Bhanu, Binoy, then Chandra, then Divya. So, if we define this relationship R in between these two, then we can Ali belongs to A belong, then B is Bhanu and Binoy. C is of course. This is called arrow diagram. Arrow diagram for representing your relation. Correct. So from this pictorial representation or diagram, we can see how first element of set A is related to the elements of set B. Correct. Now, this second element, here, you can see these. What are these? These are called image. The second element of the ordered pair is called the image of the first element. So these are the images. Ali is the image of A. Binoy is the image of B. Correct. Now, what are these? First element, this. The set of all the first element in the ordered pair of R, this is called domain of R, relation R. Correct. Set of all these or second elements means these are basically range of the relation R. And the whole set, basically here you see Divya is there. It is not the image of any of the element of the set A. That's why those who are the images, they are basically called range, domain and range. This is a, but this whole set B is called codomain. If you see this range are the only those elements which has got which are the images basically. That means it is the subset of codomain. Subset of codomain. Correct? So what is domain, what is range, what is image, and what is codomain? I think this is all clear to you. This relation this can be represented by either roster method. What is this? This is not real number, this is relation basically. So do not confuse yourself. This R relation, it can be represented by roster method also and set builder method also. And your arrow diagram is nothing but the visual representation of the relation. Correct? Now, let us see. So, it will be clear with some examples. Suppose you have a set A. Now, if I ask you, you define a relation from A to A represented by R, X, Y, X and Y, they are the elements of ordered pairs such that Y equal to X plus 1. Then what will be the R axis? If X is 1, take 1, then Y is basically X plus 1. Then this will be 2. Then if X is 2, naturally it will be 3. Then X is 3, then it will be 4. Then X is 4, then it will be 5. Then if it is 5, then X is 6. We cannot take 6 element as a first element because then it will be 7, but 7 does not belong to A. So this is the, by definition of the relation, this is the your relation R, where first element and second element, they are bearing the relationship, and X belongs to A and Y also belongs to A. Correct? If we ask you to represent pictorially, then you can, oh, sorry. Oh. Here, our element of the first 1, 2, 3, 4, 5, 6, and element of the Y, they are 1, 2, 3, 4, 5, 6. These are the, but what about the relation? If we define this relation, then here 1 bit 2 is the image of 1, 3 is the image of 2, correct? So this is how pictorially you can represent your relation, correct? Now, what is the, just see, what is the domain? What is the domain? Domain is basically nothing but domain of this relation. Here, 1, 2, 3, 4, 5. This is the domain. And what is the range? This is nothing but 2, 3, 4, 5, 6. And what is codomain? Codomain of all elements of the Y, that is 1, 2, 3, 4, 5 and 6. Correct? So this is how you can suppose if I say A is and B is, then find the number of relations. Relations are A to B. Then how many, this is basically 4, and how many number of subsets of A cross B, that you know 2 raised to power n. Here n is what? N is 4. That means 2 raised to 4. So number of relations from A to B, A or A into B, that will be 2 raised to 4. So mind it. Correct? So we have seen what is a relation, how to find out domain, how to find out range, codomain. Correct? Now there is another important aspect in this chapter, and that is called function. What are functions basically? अभी तक अगर जो भी आपने समझा है, अगर वो आपके दिमाग में है, तो इट इज वेरी इजी टू अंडरस्टैंड फंक्शन. फंक्शन मीन्स इट इज a relation f from set A to set B. This relation f is said to be if, now remember, if every element of set A has one and only one image in set. This is a very important definition. A relation f from set A to set B is said to be a function if every element of A has one and only one image in set B. Correct? So, first of all, if you see domain of F is set A. Here, domain is from the set A we have six is remaining, which has got no image in the codomain. But here, every element of set A should have a distinct image in the codomain. Correct. That means we can write it as this is if f is a function a to b and a b they belong to f. That means then fa must be equal to b, where b is the image of a under f, and a, what is a, is called pre-image. Pre of b under. So this is basically function. This function is basically always from set A to B is defined, is denoted like this: f A to B. Correct? Now let us see, let us this understand what is the meaning of this. We take a relation R 2, 1, 3, 1, 4, 2. Just see this relation is function or not. We can see 2, 3, 4. What is this? This is the domain of R. And just see 2 has got a unique image in the codomain. Then 3 has got a unique image and 4 has got a unique image. So that means R is a function. Correct? Let us take another example. Suppose your R is 2, 2, 2, 4, 3, 3, and 4, 4. Here, if you see your 2 first element 2 has got the image as 2 also and the image as 4 also. Means this element is not, if pictorially let us see, here 2, 3, 4, here 2, 4, 3. These are the basically no other thing. Here if you see, your 2 has got an image and you have got a 2, 4 also. Means in the code domain, it does not have a unique image. It has got 2 images, 2 different images. Because of this is okay. It is 3 is having unique image and 4 is also having unique image. But because 2 is having 2 images, that's why R is not a function. Correct? Let us take another example. Suppose you have R is 1, 2, then 2, 3, then 3, 4, then 4, 5, then 5, 6, and then 6, 7. Here, if you see, one, 2, 3, 4, 5, 6, and here 2, 3, 4, 5, 6, 7. One is related like this. So every element of domain, it has got a distinct image. So this is a R is a function. I hope you understood this. So this is the something about relation and function. I hope it is clear to you that what is relation and what is a function. Further in the chapter, we will go in the second part. Correct? So please do subscribe my channel, and how do you like this video? Please do tell me in the comments box. Correct? Thank you very much.